Okay, good afternoon, class. So, I gave you homework, exercise 9.1. I probably need to re-record these four songs because the phone I recorded with yesterday, I can't seem to get it onto my laptop, so I would just need to redo that. Okay, so with regards to question 5, you had to do 5, 6, 7 and 8, correct? So in this video we will look at that with those sums then. So given O, the center of the circle, we are told that AB and CD are chords. Then we are told that OM is perpendicular to AB. ON is perpendicular to CD. So if these are perpendicular, what do we know? AM is equal to MB. Also, if N1, if ON is perpendicular to CD, then CN is equal to ND. Why did I make that 1 and this 2? They're not equal. Okay. So with that in mind, we are also told that AB is equal to 30 units and OM is 20 units. Calculate the length of the radius OB. Calculate the length of the radius OB. Okay. So firstly, we know that M2 is also going to be 90. So they told us it's perpendicular here, so I don't have to state that. Okay. So can I apply Pythagoras there? What am I shorting? The fact that MB is going to be 15. So MB is 15. Why is it 15 units? Perpendicular from center to chord by 64. Okay, so there we have 15. So I'm going to calculate OB by using Pythagoras. So OB squared is equal to 20 squared plus 15 squared. Why? Pythagoras, angle M2 equals 90 degrees. So it's going to give you 425, no? Which is 20 squared plus 15 squared. 625. The square root thereof 25. So importantly to note is that if OB is 25, then OD is also 25. And so is OC and OA. All the radii in the circle will be 25. Okay? You guys understand? Because I need the space here. Now we are told that the length of CD, we must calculate the length of CD if ON is 15. Okay. So we know that OD is 25. Why? Radius. So what can be calculated here in this triangle? I can calculate ND. So ND squared is equal to 25 squared minus 15 squared. Why? Pythagoras. Well, N2 equals 9. Did I write Pythagoras in the previous one? You sure?
Yes.
Okay. This is going to give me an answer of 400. Is that correct? The square root thereof is going to give you 20. Okay. But yes?
Wasn't you first saying that N2 is equal to 90 degrees?
Into. You see, the fact that this is given 90, or that is given perpendicular, that's why I don't have to say that's 90. Because it could have lied there or there, it doesn't matter. You understand? But if they didn't state that and they only said N1 is 90, then I would have to say N2 is 90 angles on a straight line. But if you had said it at that point, no problem. Okay. But have I answered the question? No, I must say now that CD is now equal to 40 units. Why is that 40 units? Why are those equal? Perpendicular from center to chord bisect the chord. Right, people, any confusion here? You all okay, no? Why is your booklet open? You did it book. You must mark now. You guys must mark, no? You must just let me know what confused you and so on. Right, people, we're now looking at number 6. So given O is given circle center O, with PQ being parallel to RS. People, if lines are parallel, what do we know? Can use corresponding alternate or co-interior. So if that is parallel and this is perpendicular, we know that this is also 90 degrees. Alternate angles, or the other way around, or co-interior, whatever. You guys understand? So with that in mind, we are told that the straight line GOF is perpendicular to PQ. People, if GF is perpendicular to PQ, what do we know? PF is equal to FQY, perpendicular from center to chord bisects the chord. Then we are told that RS is equal to 80. R is equal to 80, PQ is 60. And the radius of the circle is 50. So I just draw from center to circumference 50. But why did I draw it particular to either to PQ, P or Q? Because then I can form a right angle triangle. Okay? So usually I'm drawing it from there to the circumference. I'm not going to do anything first. Calculate the distance FG between the coordinates. FG between the chords PQ and RS. So this is the length I want you to calculate. But there's no way I can calculate FG straight. What I can calculate is FO and OG, and then add them together. Not so? So let's work with triangle FQO first. Do I have to state this? No. Alright, so what can I say here first? FQ is equal to 30. Why is FQ 30 units? Perpendicular from center to chord bisect the chord. Okay, so that is now 30 here. Is that enough to conclude Pythagoras here?
Yes.
Yes. So OF squared is equal to 50 squared plus, no, minus 30 squared. Okay, it must be minus because I've been working with the hypotenuse. Reason? Pythagoras with angle F1 equal 90 degrees. So that's going to give us 1,600. Not so? So the square root thereof is going to give us 40 units. Okay. 50 squared minus 30 squared. Okay, and the square root thereof is 40. Okay. So OF is 40. Now, in the other triangle, so in triangle OSG now. OS would be your OS your radius, which is 50. We're getting 40. Here we are told in the radius is 40, 50.
So I want to do GS.
Okay. What is GS? Can I just say GS is 40 here? No. What do we need? We need this to be 90 degrees first. But we know that OGS is 90. Why? Alternate. Can you see that ZD? Alternate angles. Also interior. Did I have to state this?
Yes.
Why? It's not on the diagram. Okay? So alternate angles, so with the PQ being parallel to. Now we can say that GS is equal to 40 units. Why is that 40? Why is that 40? Perpendicular from center to chord bisect the chord. Is that enough to do Pythagoras thing?
Yes.
Yes. So therefore, OG squared is equal to 50 squared minus 40 squared. Reason? Pythagoras with OGS equals 90 degrees. Now somebody said G1, yes, that's fine. If you had written on your diagram G1 and 2. So OG squared works out to be 900, not so? So OG works out to be 30. Never answer the question. They want, therefore FG is going to be OG plus OF. No? Which is 17. Do I need a reason here? No. So that is not a geometry reason or theorem I'm using. Okay. Any confusion? What 8? No? Between 6 and 8. No, definitely 8. 8 one. There. Okay, let's go to number 7. Given two circles, both centered at M. This is also called concentric, okay, when they're sharing a center of a circle. Two circles, both are centered at M. PT is a just stop it please, no? You're starting early in the year with your nonsense. Two circles, both are center M. PT is the chord of the larger circle. So PT is the chord of the larger circle. Cutting the smaller circle at Q and S. Then we are told that MR is perpendicular to PT. People, if that is perpendicular, what do we know? We know that PR is equal to RT, and also QR is equal to RS. In both cases, perpendicular from center to chord bisects the chord. Okay? Then we are told that MQ, sorry, MS is 10. Just write it in black. MS is 10, MP is 17. MS is 10 and QS is 12. Calculate the length of MR. Calculate the length of MR. So MR is this length here. Not so? and there's a triangle, I can apply Pythagoras there. Not so. But firstly, we're going to say RS is equal to 36. Why? Perpendicular from center to chord, bisect the chord. Okay. Is that enough to conclude the Pythagoras there? Yes. So mr squared is equal to 10 squared minus 6 squared. The reason? Pythagoras with angle R1 equals 90 degrees. So mr is equal to 64. The square root thereof, 8 units. Okay. 8 units. Then in B, I want you to calculate the length of PT. PT, which is the whole length here, not so. But what can I calculate here? I can calculate PR first. Can you see that?
Yes.
And I can multiply it by 2 to get PT. Why? Perpendicular from center to chord, bisects the chord, which means to say cut in half, which means to also say that length is equal to that length. Do I have enough to conclude Pythagoras there?
Yes.
Yes. So what do I say? PR. Sorry, P R squared is equal to 17 squared minus 8 squared. Why? Pythagoras R2 equals 90. So go 17 squared minus 8 squared. 2 to 5. So PR squared is equal to 2 to 5. Square root thereof is going to be 15 units. Okay. Have I answered the question? No? So therefore PT is equal to 30. Why? Perpendicular from center to chord, bisect the chord. Okay, you guys understand? Otherwise, if you first want to say that RT is also equal to 15, perpendicular from center to chord bisects the perpendicular from center to chord bisects the chord, and then say PT is 30, you can do that as well. Okay, that's just an extra step, but no extra marks, of course. No. Let's do the last one quickly. Number 8. So here we are given circle with center D. D is perpendicular. DE is perpendicular to FG. People, if that's perpendicular, what do we know? We know that FM is equal to MG. Okay. Why? Perpendicular from center to chord, bisects the chord. Cutting FG at M. FG is 24. So that is 24 units there. So that's going to be 12 and 12. Then we are told that EM is equal to 8. It's marked on there. And MD is equal to X. Calculate the length of radius FD. So if you look at FD, what is FD equal to? X plus 8. Why? Because ED is also equal to X plus 8. And both is your radius. Do I need that reason there? No. It's given it. No, if you had a written radius, you would have been penalized. Okay. People, you wouldn't have. Is this enough to conclude Pythagoras there? Yes. So what do I write? X plus 8 squared is equal to x squared plus 12 squared, or 12 squared plus x squared. Reason? Pythagoras. With angle M1 equals 90 degrees. So that's going to give you x squared plus that times 2. It's going to give you 16x plus 64 equals x squared plus 140. The x squared cancels. If I bring that over the equal signs, x squared minus x squared. So So 16x equal to 144 minus 64. You get an answer of 18. So divide both sides by 16, I get an answer. People, did I answer the question? They want to know the length of the radius. Therefore, FD is going to be 8 plus 5, which is 13 units. Beautiful sum, eh? Easy. Any confusion there? No. For homework, I would like you guys to do number 9, 10 and 11. Okay.